This short presentation will give a brief introduction to the development of integrated approaches to testing and assessment, or IATA, and how they are used with the gracious framework to support grouping and read across of similar nanoforms. The gracious framework is underpinned by the generation of hypotheses that can be tested to support scientifically sound, evidence-based grouping decisions and read across. In this figure, we know the scheme of the framework. Put basic information into the framework using the gracious hypothesis template. Each hypothesis will then form the basis of a tailored IATA that allows the collection and or generation of data to allow. Specifically, the IATA are tailored testing strategies that get information from existing sources, for example, reviewed literature, reports and databases, in silico modeling approaches, and or newly generated data from experimental testing. The IATA then combines and integrates this information from these different sources together using a data matrix. As each IATA is tailored to a specific hypothesis, the user will be guided to only gather the evidence required to assess whether a specific hypothesis can be accepted or rejected. This importantly focuses the user to only generate and fill specific identified gaps. By ensuring testing is conducted in a targeted manner that allows integration of new data with existing information, the IATA approach minimizes the burden of testing required to make a grouping decision. Within Gracious, our IATA are presented in decision tree format, which aligns with the OECD recommendations. This visualization of a pathway from exposure to the target along with the potential points of departure where your nanoform may deviate from, and therefore you may reject the hypothesis. The decision tree format highlights the critical questions to be answered in order to determine whether the grouping hypothesis is valid for the form under investigation. These critical points, referred to as decision nodes, are measurable with defined criteria to ensure a clear yes or no answer. Therefore, by asking specific information, the IATA allows you to assess whether a nanoform or a set of nanoforms fits into a hypothesized. This can support grouping of nanoforms for a number of purposes, including the generation of a regulatory read-across argument between members of the group, the adoption of precautionary measures already employed to ensure safety from exposure to other members of the group. The IATA may also be used to support grouping to enable safer by design innovation by highlighting how you may alter your product to remove it from a group of materials with a high hazard potential. The information required at each decision node can be gathered at different tiers of testing, from simple acellular characterization and in vitro screen assays to more complex in vivo models and finally in vivo. A tiered approach for simple to complex testing can be used to support a grouping decision with increasing levels of confidence. The choice of tier at which you exit the IATA reflects the initial purpose for grouping and the associated level of uncertainty considered acceptable for those needs. For example, if you wish to group nanoforms for a safer by design purpose, lower tier testing may facilitate rapid and cost-effective decision making on whether to continue with development, although this may be associated with a higher level of uncertainty. On the other hand, grouping read-across for regulatory purposes will require a higher tier testing to provide greater scientific confidence in your grouping decision. Therefore, the extent to which testing approaches are needed is defined by the end purpose under consideration and the level of scientific confidence needed to justify the grouping decision. The tier testing strategy of the Gracious IATA allows for this flexibility. Thank you for listening to this brief overview of the development of IATA within the Gracious. For more detailed examples of IATA for both human health and environmental contexts, please refer to our additional videos.